Section 2.1.6 Shift Left Mindset Quality and Security Earlier. Let's start with a question that sounds simple but isn't. When is the best moment to catch a defect? Is it during deployment when everything is already connected and under pressure? Is it after a production incident when users are affected and explanations are overdue? Or is it earlier, before the defect even has a chance to grow into something expensive and dangerous? That question is the core of the shift left mindset. Shift left says something very direct. Find problems as early as you can. Problems should be detected early while they are still small, cheap to fix, and mostly harmless. And yet this idea is often misunderstood. Some people hear earlier checks and immediately imagine slower development, more gates, and extra work at the beginning. In reality, the opposite happens. Early work removes late chaos. Others think shift left is only about security and ignores broader quality like performance, reliability, or usability. That's also wrong. Shift left covers all of it. And it doesn't replace production monitoring or late validation. It complements it. Even legacy systems can adopt shift left incrementally without rewriting everything. At its heart, shift left is one of the most transformative DevOps principles. It means integrating quality, testing, and security as early as possible in the software lifecycle, not after development, not after integration, not the week before release, but from the moment design begins and code is written. Shift left turns firefighting into proactive engineering. If you need a mental picture, imagine building a bridge. In a traditional approach, you build the entire structure first, and only then test whether it holds weight. If something goes wrong, the cost is enormous. Shift left changes the logic. You check materials, calculations, and design assumptions at the blueprint stage. You prevent collapse instead of reacting to it. That's what shift left really does. For a long time, software quality and security lived on the far right side of the timeline. Requirements were written, code was produced, systems were integrated, deployment happened, operations began, and only then did defects show up, often with an oops attached. Problems discovered that late were expensive, painful, and sometimes catastrophic. Shift left rewrites that entire flow. Instead of late inspections, teams build quality at the source. This is not a small optimization. It is a structural change. Why does this matter so much? Because early fixes are exponentially cheaper than late ones. Industry data has shown again and again that fixing a defect late in the lifecycle can cost up to 100 times more than fixing it during design or coding. Studies referenced by companies like Veritas highlight this clearly, and delivery performance research consistently shows that teams practicing shift left reduce rework by 50 to 70% and lower failure rates dramatically. This isn't theory. It's what happens in real systems. Now consider what changes when artificial intelligence enters development. Machine-generated code significantly increases productivity. Large volumes of code appear quickly. That sounds like progress. And it is, but only if validation keeps pace. If teams wait until later stages to validate those outputs, risk multiplies. Shift left becomes essential. It protects teams from what many engineers describe as AI debt, where problems grow faster simply because everything else does. Some researchers describe this as a problem multiplied by acceleration. The faster you move, the earlier guardrails must appear. Interestingly, intelligent analysis can also strengthen shift left. Automated threat detection and code analysis can predict vulnerabilities before changes are even merged. Instead of discovering issues late, teams make small corrections early when they still feel trivial. Another useful way to think about shift left is as a conveyor belt. In traditional setups, testers and security auditors stand at the end, trying to catch defects as they fall off. Shift left moves those checks closer to the beginning. Defects are stopped before they travel through the system. It's the difference between fixing a leak at the faucet and mopping water in the basement, or pulling weeds when they're tiny sprouts instead of when they've taken over the garden. Shift left is not only about testing, it is also deeply about security. This is where DevSecOps becomes real. Security is woven into the pipeline instead of bolted on at the end. Research consistently shows that when security is embedded early, breach rates drop dramatically. That is shift-left security in practice. At the same time, experienced teams know that balance matters. Overloading early stages with too many checks creates noise and fatigue. Smart automation and basic security education keep feedback fast instead of overwhelming. If someone asked you in an interview how shift-left improves security in CI/CD, the answer is already here. Vulnerabilities are caught before deployment, where fixes are dramatically cheaper and risk is lower. Security scans, code analysis, and infrastructure validation happen while developers still have context and control. Comparing traditional late-stage approaches with shift-left makes the difference even clearer. In older models, bugs are discovered weeks after commits. Security audits happen after deployment. Feedback loops take weeks. Stress, burnout, and blame become normal, with shift-left, unit, and integration tests trigger on each commit. Security scans run during development. Infrastructure as code is scanned before deployment. Feedback arrives immediately. Costs go down. Confidence goes up. There is also a hybrid truth worth keeping. Shift-left prevents problems early. But the story doesn't end there. In production, teams rely on what is often called shift-right, the practice of verifying real behavior with real users, real traffic, and real conditions. Together, shift-left and shift-right form the modern reliability ecosystem. Research shows that teams combining early validation with real user testing, feature flags, and production observability reduce bugs significantly. You catch design flaws early and still learn from reality. Prevention and verification are not enemies. They are partners. This mindset connects directly to earlier ideas. When development and operations are unified, responsibility stops being fragmented. Shift-left expands that unity. Quality and security are not someone else's job. They belong to everyone. Feedback loops become faster and more meaningful. Learning accelerates. Across industries, teams have quietly adopted this approach. Streaming platforms test and review security early to deploy safely every day. Large cloud providers scan infrastructure definitions before deployment and reduce defect rates significantly. High-traffic marketplaces test on every commit to support thousands of deployments. Financial institutions cut breach rates by embedding security early. Even aerospace organizations shift validation earlier to improve model resilience. Legacy systems benefit too. When early scanning is added to existing pipelines, defect rates drop without rewriting the system. If you were asked to design a shift-left pipeline for an AI-driven application, the logic would follow naturally. You validate machine-generated code early using static analysis, unit tests, secret scanning, and infrastructure validation. Because automation increases volume and speed, shift-left prevents amplified risk. Combined with policy as code and feature flags, teams iterate safely and learn fast. Now let's slow that down for a moment, because there was a lot packed into that idea. When we talk about static analysis, we're really talking about catching obvious problems before the code ever runs. It's like taking a careful look at something before you press publish. Unit tests work a bit differently. They make sure small pieces of logic behave the way we expect, long before the whole system is involved. Secret scanning is about preventing sensitive things, passwords, tokens, keys, from quietly slipping into places they don't belong, like source control or build logs. Infrastructure validation follows the same logic. It checks whether what we're about to deploy actually makes sense before it becomes real. That servers, networks, and permissions are shaped intentionally, not guessed at. Policy as code may sound abstract, but the idea is simple. Instead of relying on written rules that people might forget, policies are expressed in a form the system can enforce automatically. Compliance stops being a late manual checkpoint and becomes part of everyday work. Feature flags play a different role. They let teams turn features on or off safely, test ideas with real users, and reduce blast radius when something isn't ready yet. All of these practices share one thing. They move learning closer to the moment decisions are made. And that, more than any specific tool, is what makes shift left work. It's not about adding process. It's about changing when feedback arrives. And if someone asked how shift left relates to feedback loops, the answer is simple. Shift left accelerates learning. Early feedback reduces rework and failure rates. Velocity becomes safe instead of reckless. So let's close the loop. Shift left exists because quality created early multiplies later. It prevents defects instead of repairing disasters. It makes automation safer, not riskier. It unifies development, operations, and security. Remember this phrase: shift left turns prevention into power. And with quality and security anchored early, we're ready to move forward toward shared ownership, collaboration, and systems that don't rely on heroics to survive. End of section 2.1.6.